Evening class, welcome to Mr. Nicholas class, mathematics class. Today we want to look at the area of intersecting region, that is the area of common region between two circles. Example is, first of all, I want to give you to demonstrate a scenario whereby you are given two circles like that and another one like that. So if you have those two circles, you can see that there is a common area here. This area, the shaded one, the one that I've shaded, is in this circle whose center is A. You can say that is our first circle. And then this other one whose center is B. You can see that this area here is shared by the two circles. It is in both, in this circle center A and also on the other one center B. So mostly this question is common, whereby you are asked to look for the area of the common region or the intersecting region. Okay, so what you need to do, we can pick a question whereby you have circle center A whose radius is 6 centimeters and another circle center B whose radius is 8 centimeters. So we can draw it this way. You can just sketch it like that. So the radius of the circle whose center is B is 8 centimeters and the radius of the circle whose center is A is 6 centimeters. And now we have a common region, shaded one, a shaded region there, which we have said that it is common to both circles. So we can draw a chord here, a chord that passes through that region. We can label it P here and Q. So we have a chord that passes through the intersecting region called PQ. So we are told to look for the area of this region. So what we need to know, first of all, what we need to understand is that so sometimes you are given the included angle, this angle here. You can be told that angle PAQ is 42. We can take it to be 42 degrees, and angle PBQ is 30 degrees. Angle PBQ is 30 degrees. So to find the area here, what we need to do is that we can draw a chord. We don't have to draw a chord. What we need to do is that I can illustrate it using a separate diagram like that, whereby this is called PQ and this is radius A and the angle here is 42 degrees. So what we can do here, you can take this region here to be A, because it is part of the circle whose center is A, and this other region here to be B, like that. So it is like that. The intersecting region is like that. So the one that is facing this circle center B, we can label it A, and this other one to be B. So what we need to do is that this is our region A. So to get the area of region A, we need to calculate the area of this sector APQ. Then we subtract area of the triangle APQ, like that. So how do we get the area of the sector? As we said before, it is 42 all over 360 times the radius is 6 centimeters like that. 42 over 360 times 22 all over 7 times 6 times 6. The area of a sector is theta all over 360 pi r squared. And that will give us 42 multiplied by 22 multiplied by 6 squared, multiplied by 6 divided by into bracket 360 multiplied by 7, you get 13.20 centimeters squared. So that is the area of the sector. And then now we have to calculate the area of the triangle APQ. Triangle APQ, the area is a half AB, whereby 6 times 6 sine 42. By this 3. So that will be 3 multiplied by 6 sine 42. That will give us 12.04 centimeters squared. So that is the area of the triangle, and 13.20 is the area of the sector. So we subtract so that we get the area of region A. So it will be 13.0 minus 12.04. That will give us 13.20 minus 12.04, we get 1.16 centimeters squared. So that is the area of region A. So this area here is 1.16 centimeters squared. So to get the other one here, I can also demonstrate that one using a diagram like that. So this is our region B. The radius here is 8 centimeters like that, and the included angle is 30 degrees. So we want to calculate the area of this region, which we have labeled it to be B. So we say we find the area of the sector, that is 30 all over 360 by 22 all over 7 times 8 squared. So that will give us, so it is 30 all over 30 divided by 360 multiplied by 22 times 8 squared divided by 7. So that will give us 16.76 centimeters squared if you give in 4 significant figures. And then again we have to calculate the area of the triangle, so that when we minus, we are left with the area of region B. So to get the area of the triangle, we can use sine rule, whereby area is equal to a half A times B sine theta. So it is a half times 8 sine 30 degrees. By this 4. So you say 4 multiplied by 8 sine 30. That will give us 16 exactly centimeters squared. So now to get the area of B, you will say area of the sector minus area of the triangle. So 16.76 minus 16, that will give us 0.76 centimeters squared. So you can see that the area of region A is 1.16 centimeters squared, and the area of region B is 0.76 centimeters squared. So now to get the total area of the shaded region, which is the common region between the two circles, you add the area of region A plus the area of region B. So area of the intersecting circle, intersecting region, or you can say common region, is 1.16 centimeters squared plus 0.76 centimeters squared, which will give us 1.92 centimeters squared. Yeah, so that is the area of the common region. So just to give a summary of what I've done, you are given common region like that. and you can see that that region is divided by a chord, and you can the region that is facing the center of B, the circle center B belongs to the circle center A, and the one that is facing circle center A belongs to circle center B. So you have to separate that. So what you need to do, you draw a sector like that, a sector of circle center A, and you can see that this region we have labeled it to be A. To get the area of this region, you find the area of the sector minus the area of the triangle. That will give you the area of this region, the shaded region here, which is 1.16 centimeters square. And then again, to get the area of region B, this one here, you can see that we have that sector here. So you can exclude this A, because this A is part of the triangle. It is in the triangle QPB. So you look for the area of this sector, that is the area of this sector, and then you subtract the area of this triangle here. If you subtract, you remain with area of B, of region B, which is 0.76 centimeters squared. So because you wanted the area of the shaded region here, which will include the area of A plus B, so we just add, you get 1.92 centimeters squared. So that is the center. That is how we get the area of the common region between two circles. I believe you have understood. Thank you.